Hi, this is Julian from Minute Earth. You've likely heard hurricanes referred to as Category 1, 2, 3, 4, or 5. The higher a hurricane's peak wind speeds, the higher the category, and supposedly the higher the hurricane's threat. The idea being to easily convey the danger of an incoming hurricane to the public. Except, it doesn't work. In 2015, Hurricane Patricia approached Mexico with the highest hurricane wind speeds ever recorded at 345 kilometers per hour, a Category 5 by a lot, and based on the wind category scale, should have made it the most destructive hurricane ever. But thankfully, it caused relatively minor damage and only a few people died. On the other hand, Hurricane Stan, which hit Central America and Mexico in 2005, was a mere Category 1 hurricane on the wind speed-based scale, supposedly the lowest threat level, yet it caused nearly 10 times more damage and killed over 100 times more people. Confusing, right? The problem is that the category scale is based solely on wind speed, but there are two other factors that are far more critical than wind in determining a hurricane's true threat. The most obvious factor is where the hurricane is likely to hit. Hurricane Patricia happened to hit a rural, sparsely populated area with mountainous terrain that quickly weakened the storm. Hurricane Stan tore through the populated Yucatan Peninsula and got stronger in the Gulf of Mexico before slamming into heavily populated central Mexico. And once a hurricane does hit, water is a much greater threat than wind. Ahead of landfall, a hurricane can push water in front of it, piling it up into a bulge called a storm surge that raises sea levels around the coast and produces massive flooding. Storm surges are by far a hurricane's most catastrophic product, followed by rainfall, which can also cause dangerous flooding. So, to accurately predict a hurricane's threat, we first need to predict the threat of storm surge and rainfall, which wind speed alone can't do. You also need to add a bunch of other things to the threat prediction model, including the hurricane's size, how quickly it's moving forward, a coastline's terrain, and average sea level. A larger storm slowly moving toward a flat, shallow coast, like Hurricane Stan, will cause the fiercest storm surge and most intense rainfall. Hurricane Patricia developed so quickly and close to the shore that it didn't have time to build up a storm surge at all, but the damage it did cause was due to flooding from rain. So if a hurricane's potential route, storm surge, and rainfall, and by extension everything that factors into predicting a storm surge and rainfall, are better predictors of a hurricane's threat than just wind speed, why don't we use all of that data to create a new category scale? In a perfect world, we would, except we haven't figured out how to reliably measure all of these things in real time. But that doesn't mean we're stuck with the unreliable wind speed scale, because there is a single measurement that beats wind speed alone at predicting destruction: air pressure at the center of a storm. Low air pressure in a hurricane pulls in higher pressure air, making the hurricane larger, creating stronger winds, and making it likelier to produce a large storm surge and lots of rainfall. We already measure air pressure in storms in real time, and it's easier to measure than wind speed. So if we replaced wind speed with air pressure to assign categories to hurricanes, we'd be able to give people a much more reliable sense of the threat. Ideally, we'd be able to use all the factors that best predict a hurricane's destructiveness to determine its category. But until then, one thing's for certain. With the current scale, we're simply throwing caution to the wind, and storm surge, and rain.